Hello everyone, I am Xiaogang. Okay, let's continue looking at our map. Okay, we move to iteration. Look, there are two ways to write the iteration here. The first way is that we use A2 and then reference this way to process every element, and here it just prints it out. Then we can also create an iterator in this place. After creating the iterator, we also use its keys and values for iteration. Of course, you can create one that has const. Director return, read, visit continuation, missing lines. You can also create this kind of container that has returning. Then we can implement this area simply. We just call this function, we call it alliterate like. Let's declare a container here. And for this container, we will use this. Then we might need to add, we can just add a few of these elements. E1, 2, D, change the name. Then we move the first section over here. Explain what this means. This place is equivalent to, this is an automatic typecast. Put your mouse over this spot. You can see that its type is actually TPair, indexsense, fstream. Here's, TPair-based. Yes, this type. This is for later because it's a template parameter. You can actually click into it to see what this is. This is a cross-platform utility. It provides some common method. Next, let's take a look. Can we receive it somewhere else? Or let's just look at it here. This is in Windows. Under Accessories, you can see, and here we have some commonly used methods. Here, we can get our maximum path. This place is very important. Sometimes, when the path written here is too long, there will be a problem. It's this string that reaches the maximum path length, so don't make your path too deep. When you use many third-party libraries, your path gets too deep. It will directly cause issues with the parameters you pass in. Also, when we perform string conversions, we will also run into this problem. Then actually, in this area, the ones we often use in these general areas, we can also get the default language, the default local one. Okay, these are some methods available on the platform. And then this can get some information about the CPU, right? Let me take a quick look. If I want to show you, take a look at that method. It's below. Okay, actually, it's also inside this. Can you locate it? In this Windows API. Actually, there are many methods in here. And sometimes when we need to bypass it, we can use the Windows API. That is, some methods, you don't need to write this C code yourself. Or C++, remove the Windows API part. You can directly implement it like this. Look, this has one. Getting the global WeChat ID, representing this operating system. This version of WeChat, you can see there is more information here. So regarding this function, we often use it if you want to make something that is similar to granting authorization. That can only be used on this computer. You then take this ID and transmit it to your own server. And mark it. This ID is valid, can be used. So what I'll explain here first is this, and we can see that local print. It should actually be printing a debug message. There aren't any visuals for this part. Then we will do it like this. Drop this red. If this one is red, right here, we'll run it later and see what it prints. And this spot is actually a variable parameter. Yes, you can do it like this. We define it like this. It's first defined into an fstream, and the fstream has several placeholders. We'll go back to the subtitle string, and these two placeholders are applied to these two locations. Actually, even if we modify it here, it can still be written this way. There must be something else. We can write it like this. We can write it like this, chair. And then they are in Tesor extreme. Then use a reference element. And here we can change it like this. The effect when executed is the same. It compiles without any issues. Look at this spot. Observe this compiled version of ours. And we call it. And there are no problems even with the maximum number of cores. Actually, if you don't change it, you just need to change a cost on the side. Actually, if sometimes we do this, or sometimes, according to the new series, we can write it like this. We call it message, and then we equal fstream pentacle. And then here we have this pentacle. We can just paste this segment over like this. Okay, then we place this data here. So it should be able to be done this way, right? Why is it like this? Because it is a TX, a new type like this. So how do we convert F data to TX? Just add quotes. Like this, we can convert it to the TX format. Okay, so let's make a simple distinction like this. We call it TPair. We call it auto. Okay, then let's look at another one. We'll just get through it all at once. Okay, is this done through a kind of detector? We will create one here. The iterator with only read permissions. Okay, the outside view doesn't look good. We can drag it over like this. Okay. New. So let's write an iterator here, like this. I see where he applies this. Okay, I will start it now. Then we will call these methods. Okay, this is the editor's map. This is it. Then we will just execute it. Let's start this. If there's no reaction here, let's take a look. Let's put a breakpoint. It actually comes into this area, but you don't know where the log print outputs. Actually, right here. You'll notice that the logs are written in this format. It looks like this, right? It's actually a little strange. This should be the way of directly outputting to this console. Looking here, there seems to be no problem. Let's move further down. See, the output here is also TPair. Shouldn't be a problem. Also, note that our TMap is unordered. Although compiling it this way makes it ordered, but sometimes the order might change. So, you must not do this inside the TMap. But regarding sequences, right. Actually, if we wanted to display here, see, displayed to our, so we can check if displayed in our editor, we might still need to use UELog. We can take a look. If we click manually here, we can cancel this here. Look, this place does not have dates. All our resources here are open. You can filter different resources here. Later, we will guide you through defining your own resources, but you can see that there are resources here. If you want your resources to be printed, you can actually write it like this. Then we also have the same two ways of writing, right? We are just providing it. Give a boarding, give a warning level day. And then, as for here, you can actually just do it like this. It's a syntax that uses variable parameters. See if there's an extra number. No problem when returning. And then actually here, you can write it like this. If you write it here, you can write it like this. Actually, we can write it like this. We will write two placeholders. Let me briefly explain this to everyone first, because just writing this word doesn't seem to convey anything. It might waste everyone's time. Let me give you a detailed explanation. Then we can write it like this here. Note that this is the fixed syntax. After you write it like this, its first parameter is actually the location of this function. That is, it will reflect the location of this function to you. And this is a standard way of writing it. Let's look at the compilation error. Yes, this is very normal. Because we have an f real world distance, you need to convert it into this center point first. Then on our end, it automatically found, hey, this spot just prints it out. Also, this front positioning range, you will notice that it prints out your class and methods, and prints them out as well. When we check the logs like this, or when checking bugs, it's much better this way. We know exactly which function segment executed what kind of result, and what kind of problem occurred. Okay, in this lesson, we briefly talked about it for everyone. The Sujita and the sustaining log, and also this situation within the platform. Thank you, everyone.